everybody. I'm John from Embrace, engineer here for going on 4 years, and one of the leads on our React Native SDK team. Little fun fact, currently in the house with me is 7 different animals of various species that I hope stay relatively quiet during this presentation.
Well, hey everybody, thank you for being here. My name is Florencia. I am a React developer and a front-end one here at Embrace as well. I worked on the development of the Embrace React Native SDK, and I recently became a triager for the OpenTelemetry JS contrib repo. And fun fact about me is that outside of work, I really love to spending time in nature. I'm really into backpacking and sports like snowboarding. So if you have any recommendation for next season, let me know.
Cool. So before we get into the core of React Native and OpenTelemetry, I did want to start by explaining Embrace briefly. There's a couple different pieces of Embrace. One is an SDK that sits in your mobile app, collecting telemetry that is relevant for mobile, and then processing that data and providing insights on it in our dashboard. But we don't just collect data in any way. We collect in a way that conforms to OpenTelemetry, which if you're not familiar with, that's okay, because we'll dive into it in a bit. But what it means here is that we can send the data we collect not only to us, but to other observability backends. So if you already have telemetry from your backend infrastructure sitting in Grafana, it can now live side by side with what we collect from mobile. But what are we going to talk about today? So a few different things. We'll start with kind of what the state of React Native support is currently in OpenTelemetry, as well as some next steps that we think would be great for the community to kind of take and improve where we are. And then we'll move on to specifically the Embrace React Native SDK and some of the benefits you get from using that. And then we'll dive into a demo where we'll show a React Native app integrated with that SDK and show the kinds of telemetry you can get out of it, both in an observability backend like Grafana, as well as in our Embrace dashboard. And connecting that all together will show how that by having both your client-side mobile telemetry and server-side infrastructure sending data to the same place, that you can enable some pretty powerful communications between your different teams. But first, I'll hand it off to Flor to tell us what is the state of React Native support in OpenTelemetry.
Thank you, John. So first, we may answer a question. What is actually OpenTelemetry? Well, as most of you probably know, OpenTelemetry is an open source framework dedicated to help people to collect, process, and export telemetry data. This is possible because OpenTelemetry introduced 3 key concepts, signals actually, traces, logs, and metrics. Here's an example. Let's create a use case of a shopping cart. A common flow into it could be the checkout process. You will probably like to know when this operation started and when it finished. For this, you could start and end a trace. This type of signal will help us to wrap operations that have duration by giving a meaningful name to it. You will also probably want to know what are the events happening while this operation is still in progress. This can be tracked using logs. They will provide useful information about events occurring in the flow. They are instants, they doesn't have a duration, and they happen at a certain point in time. And maybe once you are in this flow, you have some API calls running and displaying information about payments and installments maybe. You would like to know if they are performing right by tracking response times or the error rate. And for it is why we have metrics. They offer numerical data commonly used to track the performance and the health of your system over the time. If we continue over the illustration, there is another aspect that contributes to what OpenTelemetry is. OpenTelemetry provides a set of APIs and SDKs that help us to apply the signals explained before. They are language implementations like JavaScript, Java, and Swift. They are others for sure, but these are useful ones for instrumenting a React Native application. And with that being said, we could jump into the third key aspect that conforms what is OpenTelemetry. I mentioned before that the language implementations allow us to instrument a React Native app. But what does that mean? Well, this refers to the process of adding code to an application that tracks specific journeys by giving a meaning to the collected data. Examples of these instrumentations could be collecting data around network requests, maybe UI rendering, navigation changes, state changes, etc. So in the context of a React Native application, OpenTelemetry can be integrated to collect telemetry data from both JavaScript and native layers, making use of the language implementations already exist. These two key aspects are those crucial for this integration, but this is not that simple today.
Yeah, exactly. Looking at these pieces, it seems like we might have everything we need for support in a React Native app. We have JavaScript, Java, Swift, all kind of the languages that make up a React Native app. But it's important to keep in mind that just because we have support for the languages we're writing in, doesn't mean we necessarily have support for the runtime that our code is going to be executing in. So some historical context that's useful here to know is that OpenTelemetry began by thinking about telemetry really in a server-side environment. So that is where the most mature support is in the tooling. So for JavaScript, that's Node, and then Java and Swift, that's server-side code. And where Embrace in the community is actively working on extending maturity is moving towards the client side. So that's Android and iOS devices for mobile and browser environments for JavaScript. And the kind of very bleeding edge of all this is where React Native sits, which is not explicitly supported by any of the tooling in these languages. So as a developer, you're a bit left on your own to figure out how do you bring these pieces together in order to have observability in your application.
So how do we actually get OpenTelemetry in our apps? Well, there are two approaches for making it possible. Option A is to go deeper and work directly into the native layer, using all the available resources in Java for Android and Swift for iOS, while the other delegates the work to the JavaScript one. So why don't we just dig into the pros and cons of these two approaches? If you decide to integrate OpenTelemetry by using the existing SDKs in the native layer, what I've previously called the option A, let me tell you that you're taking a really good approach because those implementations can be wrapped in native modules, which allows the application to get benefit about the auto instrumentations happening there, such as the network requests. And by the way, I hope the concepts of native modules are familiar to you, but if it is not, let me tell that these native modules allows you to write platform-specific code that can be exposed to the JavaScript layer. The downside of taking this option is that depending on your needs, you will have to do it maybe twice because you may cover both platforms using the different SDKs. And this is exactly how the React Native Embrace SDK works. Our SDK is built on top of the Embrace Android and Embrace iOS SDKs, which will be covered really soon. As I mentioned before, when taking this option and working with the Java or Swift SDKs, there are a few things to keep in mind. One of the challenges is dealing with the inconsistencies across the language implementations, as each OpenTelemetry SDK may have slight differences depending on the platform. Another gotcha is definitely the lack in the app level context. Since we are working at the native layer, we don't have direct visibility into the JS one, making the analysis more difficult if you care about it. In this situation, what will happen is that all telemetry data will show information about native components. These native components are what React Native exposes as core and act as direct wrappers of iOS and Android, respectively, instead of collecting information about the JS components, those that are created in JavaScript. For example, let's say you would like to track the time a component takes to be displayed in the screen. What is going to happen is that the telemetry data will capture the information, but it won't have in consideration what is going on in the JS component that wrapped it. If you have some logic there that could delay the rendering, you won't be noticed. And finally, for sure, after wrapping the SDKs into the native modules, you will still need to work on the JavaScript layer to capture relevant data out of the box instrumentations, since sometimes that's not sufficient for a right analysis.
Yeah, so given all that, what about going the other direction? Can you just take the OpenTelemetry JS packages, install them from NPM, and then launch your React Native app? It turns out you can do that with some caveats that we'll get into. But this approach works because React Native provides implementations of enough web APIs that you can kind of trick the code into thinking it's a browser environment and everything kind of just works, which is great because this is a simpler way to get started, and you have immediately out-of-the-box OpenTelemetry interfaces in JavaScript. You can add custom instrumentation there and even get some out-of-the-box instrumentations working. And actually, there is an OpenTelemetry demo repository, which uses a simple e-commerce app to kind of showcase OTel working in different environments. And previously, this contained just a web app as an example. But at Embrace, we contributed a mobile app, and we built that using React Native, and we integrated the OTel JS SDKs using this approach. And we decided to do that in order to have a simpler example to follow. So that works, but it's not perfect. As an example, fetch is something that is implemented in React Native, but it's not exactly the same implementation as you would find in a browser. There's a web performance API in browser environments that is not implemented in React Native out of the box, and that's something various OTel instrumentations do rely on. And you can see kind of in this snippet here, this is code taken from that OpenTelemetry demo app that I mentioned. And you can see we have to be fairly careful. We're turning off certain auto instrumentations that we know aren't going to work in React Native. Even fetch, which is one we do want to turn on so we can capture network requests, we have to be careful and kind of configure it in this magic way with just the right attributes in order that it works for React Native without complaining. And it's not shown here, but the packages that we use for the demo app are pinned fairly exactly to versions that we know work with React Native. But it's entirely possible, because this is not a supported runtime, that during development of new versions of these tools, something could be introduced that breaks for React Native, because it's making assumptions that are valid for browser environments but not valid for React Native. And on top of all that, we're not getting much in the way of React Native specific or even mobile specific instrumentations out of the box.
But after all, maybe you are wondering why we did all of this effort. What is the value over here? Well, once the integration is up and running, the real value comes from having a complete picture of your system in one place. At this point, you already have a lot of information. If we have a good instrumentation of the system, we will be able to see information not only about our frontend, but also from other pieces like the backend or external services we consume. Going from the left to the right, we have our application sending signals when the clients use it. In the middle, we see our telemetry data representing those signals coming into the observability of preference. In this case, is Grafana. With the mobile context inject that is displayed in the third image. All this information can be hooked together to wrap up some conclusions about your application's performance, which is awesome because before we had no clue about what was going on right after your users start a new session in your application.
Cool. And so this is all a really good start, but we can go further. So where do we want the React Native community to get to with respect to OpenTelemetry? So, if we jumped ahead a year or two, what would we want to see different about the options we just went through for adding that observability? In an ideal world, doing all those steps would be something that felt natural to us as React developers, just like adding any kind of package off of NPM. And on top of that, the visibility we got would be specific to what users are actually doing on our apps. And the telemetry wouldn't just be kind of generic spans or logs, but would actually provide insightful data that let us answer questions about improving our users' experiences, which is what we're kind of doing all this for in the first place. So what are some concrete steps for us to get there? So first piece of that, I think, is actually the lowest hanging fruit. At the moment, if you look at how the OpenTelemetry JavaScript SDK works, there's a lot of classes, and the intention is you instantiate them, and it's fairly procedural and synchronous code. As React developers, it would be nice to be able to create and set up a tracer provider using a hook instead of that sort of very procedural code. Or it'd be nice to be able to put a span in the React context API rather than having to pass it through components where you might need it kind of deep in the hierarchy. And that's why I say this is lower hanging fruit because the OpenTelemetry JS SDK is used in web, and there are a lot of React web developers who would like these same sets of tools. And because, unlike React Native, browser environments are explicitly supported by these tools, there's more of an opportunity to start prioritizing some of that work in the community because it begins by benefiting a larger group of developers. And everything after that ends up benefiting both React and React Native development.
Something else that would be great to have is more out-of-the-box instrumentations. As developers, we all know that there are common flaws that we care about and we want to monitor, as they could impact performance, user experience, and overall system behaviors. But without auto-instrumentations, tracking these flows can become time-consuming and complex. Time that developers don't want to spend on manual instrumentations, or even worse, they simply can't dedicate to that. Navigation is a great example of those common flows. Here at Embrace, we started actually the process of contributing to the community by adding the first React Native specific package to the OpenTelemetry JS contrib repo. This one creates telemetry data on top of the 3 most popular libraries used for navigation. They are Expo Router, React Navigation Native, and the Wix one.
Cool. And so the final piece here, maybe the more abstract one, is going from kind of generic spans and logs to things that have more of a defined meaning. OpenTelemetry calls this semantic conventions. As an example, you could start a span when you fire off a network request and then end it when you receive a response. And maybe you got a 404 and you store that in an attribute on the span called response code. But someone else instrumenting their app calls that attribute status code or just code. Without a semantic convention, which we do have for HTTP, there's no way to know kind of all these different spans are all talking about the same thing, which is a network request. So we introduce these conventions so that all these spans have the same attribute. We enforce that it's called status underscore code. And that unlocks a lot of power. Suddenly, everywhere we're sending this telemetry, backend collectors can start leveraging the fact that these spans have additional meaning. They know their network requests, so they can start bucketing maybe all the spans they get representing network requests that had a 400 response code or higher separately from those that had a response code below 400. Because we understand from HTTP semantics that those represent different things. So similarly, adopting semantic conventions for things in the React Native world or the React world, like dispatching an action from a state management system or a user navigating between screens and tabs, this starts adding the ability to gain more insight out of our instrumentations. To say that, yes, this is a span, but it's more specifically a span that shows a user navigating from screen A to screen B, and this is how long we took to finish rendering the new view.
But for this ideal world to take place, I will definitely encourage you to contribute to the community as well. If you have questions, don't hesitate to throw them in the Cloud Native Computing Foundation Slack, or better known as CMCF. There is a dedicated Slack channel for topics around React Native where people will love to chime in. There are also special interest groups that meet weekly. The JavaScript SEG and the client-side groups are two that worth mentioning. These are great as a starting point if you are looking to proactively get involved. People in there will love to receive the help by reviewing PRs, joining into discussions and suggesting ideas. And finally, for sure, write the code, share it. Even when it could be some back and forth, you will receive a great feedback for that. But now it's time to dig into the Embrace React Native SDK. So, John, why don't you just kick it off?
Cool. Yeah, so switching gears a bit to our Embrace SDK. We talked a bit about those different approaches earlier, either building from the JavaScript side down or the mobile side up. With our Embrace React Native SDK, we decided to build on top of our existing Android and Apple SDKs. The main reason for that is that our mobile SDKs already do a really good job at solving some pretty hard problems that you have to think about on mobile. How do you safely and reliably export data from a device that might have limited bandwidth, limited connectivity, might lose connection, might crash? These are all things we don't really have to worry too much about in our React Native SDK because we leverage those capabilities from our underlying mobile SDKs. In addition, those SDKs are built with OpenTelemetry in mind, so we can collect the telemetry we want, both at the JavaScript and the native layers.
One of the key aspects of our SDK is that we speak React. We think this is crucial because developers looking to integrate our product are primarily focused on React, and they seem to feel really comfortable with this philosophy. They know how to handle components, renders, hooks, and everything related to this ecosystem. And since we speak React, we are also aware of what are the common flows we are interested in, offering auto instrumentations dedicated to capture telemetry data, such as navigation, state management, and network requests. In fact, the instrumentation focused on the navigation changes we offer is also created on top of the contribution we made for the OpenTelemetry community. Also, our SDK offers a simplified way of configuration through JavaScript, making more flexible the platform-specific configuration as well.
Cool. And then speaking OTel, all the kind of benefits we mentioned earlier about using OpenTelemetry, we want to make sure they're all still available using our SDK and not locked behind anything vendor specific. So we do expose our own convenience functions because sometimes it's nice to just be able to make a call to start a view, record an error log, and have the SDK worry about making sure it creates a span or log with all the right attributes. But this doesn't block accessing the underlying OpenTelemetry objects and just setting up a tracer provider with any other instrumentation, whether that's something Embrace wrote or something someone else wrote, and having that sort of all work in our SDK as well. You can also use the entire SDK for free without sending any data to us at all if you don't want. You just configure another collection endpoint to export data to, and we'll send data there, either in addition to us or instead of us. And in keeping with the open part of OpenTelemetry, our SDK repos are all also open source. That goes for the underlying mobile SDKs as well as our React Native SDK. So you're free to fork them and check them out.
And for sure, we can't forget, we also speak mobile. Under the hood, our native SDKs, the Android and iOS one, are still doing a great job performing most of the important operations that are related to mobile. At the end of the day, what we care about is still running in a device. And our native layer for each platform is still taking care of detecting what is going on there by monitoring performance issues, exporting data, and collecting stack traces for native crashes when it's relevant. But now I will hand it over to John, who will be kicking off a demo for us.
Cool. Thank you, Flor. Cool. So I mentioned a couple times this OpenTelemetry demo. You can see here, this is the web app that was sort of already a part of the demo. It just sort of has a fake store selling telescopes, so you can kind of click around and add to cart and place an order. What we had ended up contributing at Embrace, this is running in my Android simulator here, but a React Native application that kind of mirrors that same retail store. So in the same way, you could kind of click around, add stuff to cart, do kind of a checkout flow and all that, and it's going to be recording telemetry, so you can see what that kind of looks like for React Native application. And this is actually a fork of the demo where we replaced the OpenTelemetry JS SDK with our Embrace React Native SDK. And that's been set up to send data both to us as Embrace and to Grafana. So we can kind of see what data looks like sent to those different places. Here, for example, is Grafana, and it's a view to the various logs we've sent from that application. So you can see here, there's a handful of logs representing either a successful checkout or an error log that for some reason we failed to place an order. And that's sort of either one by one, being able to dig into these individual logs, or shown in kind of an aggregate view, what are our rates of getting these success logs versus error logs. And then digging into specific ones, you can see there's a whole bunch of attributes associated with this log. Some of these are based on standard semantic conventions from OTel, where we have them, flagging certain fields as being, if this is representing a crash, what was the actual message for the crash, what was the error type. Other fields are things we've added that are Embrace specific, adding some additional information that we find useful. Some of these fields aren't super easy to dig into in this format. For example, we have the stack trace for the crash here, which is super useful to know where in the code did this exception happen, but without having a source map, without symbolicating, pretty difficult to dig into in this format. Yeah, this log will have a combination of kind of generic attributes and Embrace specific ones. Similarly, we can look at spans and how they show up in our Grafana dashboard. This, for example, is a span that Embrace spits out when it detects the completion of a user's session. So a user kind of going through the app and doing various things. You can see we've attached some events on here representing, adding various items to the cart as the session was in progress, and other attributes detailing, what kind of mobile device was this person on? Were they on Android? Were they on iOS? And kind of getting all that information collected here, which is great. But you know, it's not necessarily the easiest to dig into when you have a lot of these sessions going on. This isn't necessarily a user-centered view here, so it could be that all these different spans representing sessions were the same user coming back at various times and doing other interactions, or it could be multiple different users doing different things. It's kind of a matter of digging into these and sort of sorting that picture out for yourself in this kind of format. But let me switch over to the Embrace dashboard and have Flora kind of walk through what some of this information looks like there instead.
Thank you, John. Well, yes, definitely this is all great information, but what if we want to follow the journey of a specific user? What happened while they were trying to make a purchase? This is where a user-focused observability tool makes the real difference. And by the way, using the Embrace React Native SDKs give you the ability of sending the data to any OTel compatible tool, but in this case, we will focus on what Embrace offered using our own dashboard, as Sean mentioned. What we can see in here is the user timeline page. This is the place where things converge. At the very top, we can see how sessions from the same user are ordered chronologically. We can hover over each of them to see if there was a relevant event that caught our attention. If we jump into the next component, we see an horizontal representation of those events happening in the current session, which gives you a sense of what happened even before getting into the details. The events here are categorized and grouped by type, so you could span the categories present there to get more insights. If you scroll down a little bit the page, we will find the timeline details. This is core for the page. This table is showing the full event list that happened in the session ordered by timestamps. You will usually see an event representing the start of the session and probably will be followed by an appearance of a view. If we keep scrolling through the rows, we see in this scenario a couple of network calls and some breadcrumbs. Those breadcrumbs are indicating that the user just added product into the cart. If we move forward, we again see some of other network calls. And they are all in green. Nothing gets our attention just yet, until we discover a red one, a network call that returned an error. If we keep scrolling a little bit down, it seems like the user just navigated to another screen, and that action is just followed by an error log. If we open it, we can see more information about the log, such as the attribute attached there, and the most valuable entry, the symbolic stack trace. If you remember what John already shared, this is the same stack trace, but in a more user-friendly way. This is one of the benefits of using our platform. We get all the signals and process the data for you. And we can continue scrolling. We see other events until we reach the end of the session. This one ended in a crash. And again, the symbolic stack trace makes the difference because you know exactly what went wrong and where it happened. This is now getting a lot of sense because it is telling you what is the exact line of your code that threw the problem. And this is the known area for you, right? But yeah, this is all right, that we can see the events from one user into the session context, but for sure we can't spend the whole day looking at individual sessions. Because Embrace is not only that, we offer an observability platform where you can monitor your app performance in powerful ways. You can create custom metrics, visualize them in dashboards, and create alerts. And this is all possible using the telemetry data we already collected. And these insights are really great for your mobile team. But what if you have a larger engineering team interested on this data? That's where our powerful data forwarding feature comes into play. We can forward the metrics we care the most about to our central observability solutions like Grafana to connect the mobile data to the rest of your observability data.
Cool. Yeah, and if I kind of click through, like Flora was saying, and decide this is an important metric, not just for me to see on the mobile side of things, but to connect with potentially other information from my server-side telemetry. I can choose to forward that to whatever data destination makes the most sense. If we end up selecting Grafana Cloud, we can start building similar widgets in our Grafana Cloud instance, and we can have those live alongside whatever kind of information we think is relevant to look at from the server side. So maybe it makes sense to pair the frequency of seeing checkout failures in our mobile app with 500 response rates from our server, or some other outage or things that we can detect from the server side. So this is what lets us do that. We can find that kind of key bit of information, send it back over here, and start tying those two sides of the picture together. And then we can kind of look on these charts and say, oh, okay, there's something relevant here. I'd be interested to know more information on the client side again. So this would include a backlink to Embrace, where we can then kind of complete that picture and go full circle. Now that I've decided this is interesting after correlating it with my server-side telemetry, I'm back into Embrace to see, okay, where's some more information about this log? How often am I seeing it? Am I seeing it on the latest version I released on the mobile side? Cool. So that's what we want to show for the demo. And just to summarize a bit, we saw how you can send telemetry directly from our SDK into both Embrace and your observability tool of choice. And we saw how that data looked in both places. And as well as some of the additional insights layered on top of it when we looked at it in the Embrace dashboard specifically. Finally, we saw how you can kind of connect all this tooling together to get your team speaking the same observability language and creating powerful workflows between mobile teams, DevOps, SREs to solve those issues together.
Thank you, John. I really appreciate it. We covered a lot in this webinar, but here are a few takeaways from my side. So even when the React Native support by the OpenTelemetry community is still limited today, we trust this will grow and will get better over the time. But in the meantime, the Embrace React Native SDK fills those gaps by combining interesting mobile context with the efficient telemetry collection. And on top of that, the Embrace dashboard plus the various integrations we provide gives you the powerful tools to observe and troubleshoot issues, giving you the clear understanding of what your users and your business. And before we end this presentation, I would like to again encourage you to contribute. We are very, very excited for the future, and we hope to see you in the next CNCF community soon. Thank you.
So we just have a few things before we wrap up. So first of all, if you think of any questions after this webinar, and you very well might, John and Fleur covered a lot of material, so don't worry, we're not going to leave you in the lurch. Please feel free to reach out directly to John and Fleur via their emails. It's firstname.lastname@embrace.io. They love chatting about all things React Native and OpenTelemetry, so don't be a stranger. Also, if you'd like to learn a bit more about Embrace, you can learn all about our product, what we offer, how to try it for yourself by going to our website at embrace.io. And secondly, if you'd like to dig in a bit and try out some of the stuff that we covered today, you can. So our open source React Native SDK is on our GitHub page. You can find it on the link here on this slide. Also, you'll find a link to it on our website. As well as you can find the OpenTelemetry React Native demo app that John demonstrated that was integrated with the Embrace SDK. You can try that out yourself as well. The link is here on the right side of the screen. You can also find all of our open source software, including our other SDKs, like our native ones for Android and iOS, They're all on the Embrace GitHub page. So definitely go feel free to check them out, fork them, try them yourself. And with all of that said, I want to thank John and Floor again for this wonderful presentation. I hope this was helpful for you, the audience, in getting up to speed on the state of React Native support in OpenTelemetry, as well as what things to look for when you're evaluating your React Native observability. So thank you, everyone, for being here today, and have a wonderful day.